Let's move on to number 17, problem number 17 of the study guide. This section is asking for inverses, so we're going to look at how do we find the inverse of a function. And we've been discussing the 4 steps that it takes in order to go from a function to its inverse. So let's look at number 17, f of x is equal to 5x plus 5 divided by 3. Well, the first step just tells us to rewrite the problem and to substitute the function notation, the f of x, with the value y. So because f of x and y are both inputs, they're actually the same thing. So I'm going to rewrite this as y equals 5x plus 5 over 3. And that's the first step, step 1. Step 2 just tells us to switch the x and the y values. So what that means is I'm going to rewrite this as x equals 5y plus 5 divided by 3. So all I did was switch the x and the y. And then step 3, that's where we solve for y. So that's where the work actually comes in. Step 1, step 2, step 3, we need to solve for y. What that means is you want to get the y by itself. Let's isolate it. So let's move everything from over here with the y value. Let's move the 3, the 5, the 5. How do we start? Well, let's just go ahead and clear out this fraction that we have, because literally we have a fraction, this expression over this denominator. So in order to eliminate the 3, the denominator 3, if you notice it says 5y plus 5 divided by 3. Well, the opposite of divide by 3 is multiply by 3. So I'm going to multiply by 3. Of course, whatever you do to one side of an equation, you always do to the other. So I multiply by 3 on the left side also. So here we will essentially eliminate this denominator and that 3 because we're multiplying. And let's do the work over here. 3 times x is 3x. And the only thing we're left with now is the 5y plus 5. So we're getting the y by itself. We're getting there. Now I need to go ahead and move my constant. This is a plus 5. I need to do a minus 5. Whatever I do to one side, I must do to the other. These cancel. I cannot combine 3x and a negative 5, so we just bring them on down. 3x minus 5 is equal to 5y. Okay, we're getting closer to getting the variable y isolated. Last thing I'm going to do is divide by 5, because this is a coefficient of y that reads 5 times y. The inverse of 5 times y is to divide by 5. So I'll divide by 5. Of course, whatever you do to one side, you do to the other. These will cancel. So what am I left with? I'm left with y equals 3x minus 5 divided by 5. So there's one final step that we're going to do. We're going to actually rewrite this y value and put it back in function notation. So it'll look similar to this, but instead of f of x, we're going to write f inverse of x. And that's a negative 1 exponent is equal to the inverse of f of x, which is 3x minus 5 over 5. So this is our final answer when we're asked to find the inverse of this function. We're going to do the same with number 18. So here we need to find the inverse of 4 plus 1/2 x. All right, we're going to go through the steps again. The steps tell us, step 1, rewrite this as y equals 4 plus 1/2 x. Step 2, let's switch the x and the y. So x here, 4 plus 1/2 y, and then solve for y. So that means we need the y by itself. Let's go ahead and eliminate this constant by introducing a negative 4, because this is a positive 4. Whatever I do on the right-hand side, I have to do on the left, always. So here I'm left with x minus 4. And what we have left over here is 1/2 times y. So I need to eliminate this coefficient, 1/2, that's in front of the y, because we need the y by itself. Now this says 1 divided by 2. So what I could do is I could actually multiply by the reciprocal of 1/2. And of course the reciprocal of a fraction is when you flip it upside down. So if I do that, I'll just squeeze 2 over 1 in here, but I got to do it over here also. So these cancel out. There's my y. Isolated, just like we needed it. Now let's work this side out. Now what is 2 over 1? It's 2. Anything over 1 is itself. So 2 over 1, this essentially is just 2. So what I'm doing is I'm multiplying 2 by x, which is 2x, and 2 times -4, which is -8. So here's my answer. Of course, the last step, and most of the time on the assessments, you will see where we've written that y back into function notation. So that would more than likely be f inverse of x. And that's the inverse of the function for number 17 and 18. Okay, let's go ahead and finish up with number 19 and 20. All right, number 19. So for 19, again, we're still finding the inverse of a given function, but then after we find the inverse, we're gonna graph it. But we're gonna start out by graphing the function itself. So we're gonna graph this, and when we graph this, we're gonna actually use Desmos in order to get our graphing done quickly. We'll graph the function, find the inverse, and then graph the inverse on the exact same coordinate grid. So let's start with the function. G of n is equal to 8n minus 13 divided by 9. And let's go through the steps again. And for the sake of using Desmos, where we are allowed to use the x variable or the y variable because of the coordinates, x and y coordinates, I'm gonna go ahead and just rewrite this. Let's make this f of x, something we're familiar with, and let's make this 8x minus 13. And this is gonna help when you actually graph them. So now when you go to Desmos, you're gonna put in, you can put in f of x is equal to 8x minus 13 divided by 9. When you enter it into Desmos, go ahead and put these in parentheses because it'll keep those groups together. That way when you put it in, it won't read as 8x minus 13 over just the 9. It'll be 8x minus 13 over 9. So once we graph this and see what Desmos gives us, and we're gonna put it on the graph here, and it'll be somewhere up in here. Somewhere in here, so these are 2 points that you should see similar to this. So this one is this function, the f of x function. Now let's go ahead and do the inverse, find the inverse of it. So step 1, remember we're gonna rewrite f of x using y equals 8x minus 13 over 9. That's step 1. Step 2, we're gonna flip-flop the x and the y. Make this x, make this y. And then we'll solve for y. So let's solve for y. So we're gonna multiply by 9 on both sides. That cancels. We'll end up with 9x, because 9 times x is 9x, equals 8y minus 13. Okay, let's go ahead and eliminate 13. So we're gonna add 13 to both sides. We've got 9x plus 13 that comes down equals 8y. Now to get the y completely isolated, you want to eliminate the coefficient 8. So that means you divide it on both sides. So I'm gonna go ahead and rewrite my y as f inverse x is 9x plus 13 over 8. And then we will put this inverse answer, or inverse function, into Desmos so it can graph it for us also. And it'll be somewhere up in, it should look similar to this. So something like this when you graph it. Okay. Let's go ahead and, I'm gonna go ahead and show you the exact graph of that function. So I'm going to go ahead and let's move this out of the way so you can get a clear picture of it, so you know exactly what it should look like. So once you graph the original function, which is right here, that's the original function, and then the inverse function is here. And there's the answer for the inverse function that we just worked out. Let's do number 20. Problem number 20, again, we're going to graph the original function and then we'll find the inverse and graph that on the same table. So for the graph of the first function, the original function, we're gonna use Desmos again. So, and it will, the graph should be somewhere up in here. But once you put it in Desmos, you will get a definitive graph there. And for this one, just for the sake of using Desmos and knowing that we've got x and y coordinates, I'm just gonna rewrite this function notation to f of x is equal to -4 plus 1/2 times x. First step, rewrite this as y. So this will be y is equal to -4 plus 1/2 x. We're gonna switch the x and the y. So this will become x. This will become y, and then we will solve for y. So let's go ahead and do that. Let's go ahead and I'm gonna move this over here so I'll have room to work. Let's eliminate the -4 by doing a +4. Remember, you do the inverse of whatever you're trying to remove. So plus 4 here equals 1/2 y. Let's get the y by itself. So since it's 1/2 times y, and this is 1 divided by 2, I can actually multiply by the reciprocal, which is 2/1. Whatever I do on one side, I have to do on the other. These will cancel. When I do 2/1, which equals 2, I multiply 2 times x, I'll get 2x. 2 times 4 is 8, and that leaves my y. I'm gonna rewrite this using the inverse function notation, 2x plus 8. All right. And now we're gonna graph this function on the same coordinate grid. But there's your inverse. And what I'm gonna do is I'm gonna go ahead and show you the answer so you can get precise graph here. So just take a look at the actual graph. So this is how your graph is going to look like. This is the original function, and here's the inverse function. And of course, there's the inverse of that original function. All right, let's finish up with problems number 21 through 24.